All right, so we're going to talk, this is PUT, Power and Utilities 302, Smarter, Sustainable Future with Alexa Connected Home. So my name is Ralph Kapoloff. I'm BD for Power and Utility Solutions. Got a long history in real-time automation. Spent 10 years running Rockwell Software, and the most recent 10 years running the transmission and distribution R&D team at General Electric, and now I'm here with Amazon.
Hi everyone, my name is Matt Fuselier. I'm an IoT architect with AWS Professional Services, and I've worked in various industries, power and utility, as well as healthcare, education, and mostly focused on implementing IoT solutions for our customers.
So most of the examples that we're going to be talking about today are about residential generation and consumption of energy. But most of the principles of monetization of control, Lambda, green grass, machine learning at scale, it applies to almost anything else that's going to use residential IoT. So for instance, smartwatches, smart scales, all the things you can do for health of home occupants, it's going to be almost the same technologies that would be required for that. So after the session, I'm sure since this is Wednesday, you've all heard this already, but sometime apparently Matt's session was posted within 2 days. But generally within a few days, the presentation will be posted, the slides on SlideShare. So you'll see a lot of links with the data that we used. Those links will be live in the SlideShare PowerPoint or SlideShare printout, and then the whole presentation will be on YouTube. Now this is just one use case of many where AWS is involved with power and utilities. So if you want to see some of the other use cases that we've done, there's the link to aws.amazon.com, power and utilities, and that has the other use cases that we're involved in other areas. So let's talk a little bit about energy and what's changing in the energy, and there's a number of factors. The one we talk about a lot is the 3 Ds, so decarbonization, decentralization, and digitization. And this is spurring a lot of different things across the industry. But one of the big ones is direct customer participation in the energy grid. And customers are generating energy, they're being much more aware of energy because of vehicles. And they have expectations from the utility about what they're going to do with the information they're getting from the customer. So one thing the utilities are dealing with is how do we move from being just a supplier of a commodity kilowatt to being an actual partner with our customers. So move beyond just a monthly bill into a kind of more of a relationship. And so the first thing they're trying to address is what's our customer relationship? How do we deepen that relationship with the customer? Have it be more than just a bill and a disconnection, but something more creative, with the intent of creating a business that's beyond just supplying kilowatts. So how do you get from just supplying kilowatts to being an energy partner? How do you maximize the value of a customer's solar panel, for instance? How do you minimize their energy costs? And then eventually branching out into how do I help the same customer with home security? How do I help the same customer with health monitoring? Because the utility already has a 24/7 operation. It's just a matter of using it in different ways. So this is an important slide. Let's talk a little bit about globally, and these are global numbers of how the industry looks. Where's electricity from? Where does it go? So if you look on the left on the sources of electricity, you can see one of these is not like the others. So everything on there except the green slice is what we call dispatchable energy. Gas, coal, nuclear, even hydro. This is where I know a long time in advance, days, months in advance, how much energy I'm going to get at any particular time. But that little 6% green slice, that's called intermittent energy. So when the sun's shining, I get it. When there's a cloud, I get less. When there's wind, I get energy. When there's no wind, I get less. And this little 6% here is very destabilizing to the grid today. Now, if you think about the real targets that are coming out, California, it's going to be 33% renewable by the end of 2020. And they're going to make that because they got 16% hydro and 19% intermittent. But by 2045, they want to be 100%. So if we can't stabilize the grid at 6%, we're not going to get to the next level. So then you get to who uses energy, and you can see it's kind of split between industrial, commercial, residential. And so the problem statement is really how do we use flexibility in the residential market to balance the 6%? Industry's already quite involved in some of these balancing programs. Commercial looks a lot like residential. It's just actually typically a lot easier. But residential is a big opportunity for everyone. So let's take the generation side of this. This is Denmark. If you look at kind of the early 2000s, Denmark was the normal central generation type environment, and they had probably less than 100 generators generating energy in the grid. And keep in mind, there's no appreciable storage in the grid. You have to balance supply and demand on a second-by-second basis to keep the grid stable. 5 years later, they had more than 10,000 generation sites in exactly the same network with almost exactly the same population. So they had a 100x increase in the amount of data they were dealing with just for basic grid stabilization because of generation. So on the use side, this is a demand curve. You might have seen this. It sometimes gets called the California duck. There's a whole creative way why it becomes like that. But this would be a normal California day. This was probably roughly 14 to 15% intermittent renewable at the time this data was collected. And you can see you're trucking along at night, and you see at the bottom, you see the 24-hour, 1 a.m., 6 a.m., 12, all the way. So that's how you look at what a typical day looks like from electricity usage. And you start at about 19 gigawatts, and a gigawatt is quite a bit of energy. And it's going down as the night goes on. Everyone starts getting up, making their breakfast, getting ready for work, but then the sun comes up. And that's where this 15% really causes, it starts driving the actual amount of energy that's being supplied to the customers down. That's not a problem. The problem is right there at about 4 p.m. You're asking a system with 12 gigawatts of energy going through it to go to 24 gigawatts in about an hour and a half. There's not a lot of things that can do that. Very destructive to the equipment. It's very hard to do. Coal-fired plants warm up over hours. Even gas turbines, it's hard for them to keep up with that ramp rate. We're at 15% renewable, and we can't keep up with it. Now, there was a program in the past called demand response, and it was a very crude program where you could, on a time basis say, hey, I'm going to hit a peak, and I don't want to run. So the utilities have peaker plants that run like 3 weeks a year just to handle this. And we're going to schedule a bunch of stuff to go offline and then come back on. That's not what we need. If we want to balance the load, we need something much more granular. We need to get down into the device level. And so we need to do things like charge the cars in the middle of the night if there's wind. And we need to charge the cars in the middle of the day when there's a lot of sun. But at the end of the day for the ramp, we got to turn all that stuff off. We got to build thermal capacity, heat up the hot water heaters in the afternoon for people to take a shower when they get home from work, not when they come home from work. And so what we need is luckily there's a good IoT infrastructure to help us, but it's going to require that. But it does create a little bit of a load on the system we already have a 100x increase in the supply side I/O. If you look at the demand side, you can control about a 1 million home system with about a 100,000 point SCADA system, give or take a bit. But you say, I'm going to do smart meters, you get another 800,000 points. You say, I'm going to involve maybe 40% of my home in a demand response program with 4 devices per home. So typically water heater, pool pump, electric car, that sort of thing. A couple people put in solar, 10% of your people buy cars. Now you got 2.6 million points with exactly the same number of houses, exactly the same population. So that's a 26-time increase. But you're also measuring this data much faster than you ever had. So easily 100x. So you got 100x on the supply side, 100x on the demand side. And you got to make this work. So what does it take? Closed loop control is fairly straightforward. You need observability, controllability, but most important, you need monetizability, right? Because these things are expensive to set up. Cloud is really good at that bottom one. So collecting millions of endpoints spread out over millions of acres, up into the cloud. And Matt's going to talk about, all the techniques we have doing that. The controller is important because you're going to end up with a situation where you have a very time-boxed calculation to finish. So something goes on wrong on the grid, you have a limited amount of time to figure out what you're going to do with it before things go bad. And so you need to be able to scale up the amount of computation you need to hit that time box. But the next two are also really leveraged the cloud a lot. So end user engagement. Unlike industrial and a lot of commercial, you're dealing with a relatively non-technical user. They don't know Python. They don't know coding at all. Many of them don't have a computer. Some of them may not even have good internet access. And they need to have a way because they need to give you permission to control. Because the contract between the utility and the customer is you turn on the light and the light comes on. Now you're asking the customer, say, we would like permission to not have your heater on or to delay when you charge your car. So you need permission to do that from a non-technical customer. And then the other one is monetization. So you've got all this data coming up, but if you can't monetize it, why would the customer give you permission to have the data if you can't turn that into some value for them? Initially people are altruistic about green energy, but eventually they're going to say, hey, I want to get paid. Because if they're not getting paid, they're going to find someone that can pay them. So you got to think hard about your monetization mechanism. And this is where the cloud and its ability to integrate many systems in near real time comes together. So getting this out at scale, if you look at the number of real connected homes at this point, it's a relatively low number as a percentage. And if a utility really wants to go full scale, and let's say automate 1 million homes in a year, this is a big number. You somehow need to roll out 80, 90,000 homes a month. This doesn't happen by putting an ad in the Home Depot magazine and away you go. You have to have a program. And so we're working with several utilities on programs at that scale. First part of the program is the voice interface. So there's the Alexa device itself, but Alexa is now appearing in a number of other devices. So that's one aspect of it, creating the permission system. The second is the smart devices. You want to do 1 million homes, 4 devices per home. You got 4 million things deployed, which means you have 6 or 8 times that number in inventory so that customers have selection when they go to the website to pick what they're going to put in their home. That happens to be something Amazon.com is pretty good at. So utilities building warehouses to store a bunch of smart devices is not really the way to go. Let Amazon.com take care of that. The third group is a group called Amazon Experts. It's available in roughly 25 cities. And it solves the critical last 25-foot problem. So there's 25 feet between the front door and where this thing's got to go on the wall. And most users don't have the ability to make that 25-foot leap. You know, connecting a thermostat and actually wiring it to their furnace. Most customers don't want to do it. So we have a program called Amazon Experts. These are people, Amazon employees. They come out to the customer's home. They put the device in, but most importantly, they don't leave until the customer demonstrates that they understand how to use it. The big metric there is TTS, right? Time to top shelf. How long does it take for the customer to say, I hate this thing in my kitchen, and they put it in the top shelf, and it's gone forever? So that's what the experts, but you know, this is a program when you talk about 10,000, 20,000, 30,000 houses a month. You know, these are the 3 elements you've got to have in place. Now, Matt's going to talk a little bit more about the details of how this happens.
Thank you, Ralph. All right, here we go. So Ralph already outlined the proliferation of generation sites and the upcoming also proliferation of smart homes. And what that means for you as a utility is you have a lot more items to be able to gather data from and monitor and connect to. That gives you a pretty big challenge in which AWS can help with the scale and the flexibility and the agility for you to be able to bring all of that data into your system. So if you think on the generation side, you're going to have different size of asset that you're going to be connecting to, residential, commercial, grid scale. They're going to be a little bit different from each other, so you need to be able to adapt to all of those. You're going to have a wide variety of different protocols that you want to use locally to connect to those devices, to inverters, to solar panels, wind turbines, and things like that. You're going to have a variety of manufacturers, and so on and so on. So really a wide variety of points that you need to integrate into your system. Similarly, in the smart home and residential area, you now need to think about integrating with a lot of vendors as well, right? So smart thermostat or smart heater or pool pump or an electric vehicle, a charger, battery. There's going to be, again, like a multiplicity of provider out there, and you're going to have to be able to react fast because some of those new products are going to come on the market pretty quickly. And if you want your solution to be able to take advantage of that, you're going to need that agility that the cloud can provide to be able to onboard, you know, a new model of thermostat or a new provider of smart home solutions. And so you're really going to need to be able to connect to all of those sensors, to bring all of that data back into your systems, to be able to make smart decision on what you want to do to regulate the grid. So if we look a little bit at what kind of device you're going to need to talk to, we can usually separate them into categories. On the top right of the slide, you can see more into the residential area. You're going to need to interface with devices that you do not own. You don't know how they're connected. You have no control, not really much control physically over them. And one good way to do that is most likely going to be through the use of APIs. And you're going to have to interface with the vendor of the device, their platform. Maybe you interact with the device itself through an API, or maybe through an intermediate platform. Again, this is going to be rapidly evolving, so you need to be able to take advantage of the speed that AWS gives you. And then on the bottom left, you can think of maybe some of the generation assets where you're going to have a lot more control over. So maybe you own those assets, or maybe you operate them on behalf of third parties. But you're going to have a lot more control on those type of assets. You're going to be able to build custom solution to interface locally with all those devices and get the data that you need. So you can think of Amazon FreeRTOS to implement some microcontroller units to be able to get to some of that data, and or AWS Greengrass if you're thinking of a little bit more powerful computers or gateways that you can deploy on site, be able to interact with the different local protocols, industry protocols, as well as take advantage of the local compute that you might have on some of those devices to make smart decisions at the edge, or clean up the data, aggregate the data a little bit at the edge so you can really optimize what you're trying to do, and also be cost effective, as well as how you're using the bandwidth or the connectivity that you have between those sites and AWS, which might be intermittent or not very broad. And so that gives you really an opportunity to bring all of that data into the cloud, into your brain, the controller, where you're going to actually be able to ingest that data, crunch it with external data as well, maybe from third party or forecast, weather forecast, and things like that, and actually make decisions on, okay, what do you want to do to stabilize the grid? And now you're going to have to send commands back to those devices. So let's focus a little bit on the device that you own. There is a good way to send those commands back is through a design called device state replica. So I invite you to go check out a website that we recently published at iotatlas.net, and it has a variety of different design patterns that we use in the IoT world. It's not at all AWS specific. It's really for IoT solution. But that concept of state replica is critical for sending command and control and state change to your devices. It really allows you to have a loose coupling between your system and your devices at the edge, and be able to gracefully handle loss of connectivity or intermittent connectivity between your devices and the cloud. Your system can easily post a command or a state change into, so that state replica is implemented in AWS as the device shadow. So you can post that request to the device shadow, and then if the device is connected when the request is posted, it's going to get the request right away, be able to act on it, change its states, or execute a certain command, and then report back to the cloud that, okay, I've executed that command, I'm now in the state that you were expecting me to be. And if the device is not connecting at the time, whenever it goes back online or whenever it gets powered back or something like that, you'll still get that notification, and you will be able to write the business logic at the edge on what to do with those kind of updates. And you can look at, when was the last update sent. If it was sent maybe a minute ago, you might still want to act on it and turn on and turn off whatever the action was asking you to do. But maybe you lost connectivity for 24 hours or something like that. And so you're going to have that business logic at the edge, being able to make the decision on whether or not you want to act on that state request, that state change request. Most important, whether you act on it or not at the edge, you're still reporting back to the cloud. And that's a very important piece, because you're going to need to get that acknowledgement in your solution to be able to take into consideration, okay, which devices actually received an order or a command, executed on them, and reported back that they were in the right state. And that, again, is going to allow to fuel your next decision making based on those answers. So pretty key concept for command and control using the AWS Shadow from the AWS IoT Core service. Now, what happens with the device that you do not own, right? You don't have direct access to them. Ralph mentioned earlier, you're going to have to ask permission to the owner of those devices. So if I own a home, I have a smart thermostat or an electric car charging in my garage, you're going to have to ask me permission to access the data, as well as send command and controls back to my devices. And some of you might be excited to see some JSON policy on the screen, but I can assure you most of your typical homeowners are not going to be well-versed in technology. They're not going to be able to really interact with technical systems. So that's really where Alexa can come in and help you out. Alexa really brings a really simple UI, frictionless for your users, some very easy way for you to ask permission to access some of those devices, record those permission in your system, be able to generate the right authentication tokens, linking of accounts, the right policies to be able to access those devices on the field. And so very key to use a really simple way to interface with the user. Now, on top of the permission, that's probably going to happen once. You're only going to ask permission to access the device probably only once. But you also want to be able to get more information from the user about their behavior, because the decision that you're gonna make in the cloud about turning a heater on or off, you don't want them to impact negatively your customers. And so you need a way to also get more data out of your customers on when can you do what kind of actions on their distributed resources. Again, Alexa is very good at that, and with very simple phrases like Alexa, I'm leaving, Alexa, I'm working from home today, Alexa, keep the house at a certain temperature. You have a very easy way to get that information from your customer, ingest that into your system, and really realize, okay, today that person is not home, so I have control, and they left their car in the garage, so I have control over the battery in their car to store or draw electricity to stabilize the grid. Or I can use their water heater or something like that. But if the person says, hey, my kid is sick, I'm working from home today, then you definitely do not want to bring the thermostat down and bring the temperature down in the house, because that would be very bad experience for your customers, and they're not really going to be happy about that. So we run some of those programs with some of our customers, and we've got some really good results from a pilot program. So the customers that actually participate in that program were able to pretty much get up to 20% economy on their utility bill. So for most of them, like a full month of free energy per year. So that's really some good results. So now that we're here, you're really able to connect to the smart home, get the data that you need, send the commands and control to regulate the grid based on what your users are telling you, to not really have a negative experience for them. And that's only one piece of the whole solution. So that's really controlling the smart home. And I'm going to hand it over back to Ralph to tell you about the rest of the system.
All right, so if you do all of the stuff we've talked about so far, you get the pink square, right? So you have now successfully connected a home to the cloud. You've created a permission infrastructure to get permission to control. You've generated some value from some simple voice commands for the customer, but you haven't monetized anything. There's nothing you can sell at this point if you're a utility. So while it's all very interesting so far, you haven't created anything that's sustainable, anything that's going to go for a long time, anything that's going to grow to eventually solve some big, difficult problems. So the next level up from that, first you got to aggregate everything besides the home. There's commercial, industrial. There's even backup generators. They use fuel, but there's still a distributed resource out on the grid. First thing you need to do is aggregate a fleet. So minimum bid size on the PJM market's 1 megawatt. That's the full load of about 800 air conditioners. But you can't turn off all the air conditioners in the area when the use is high. You can turn them off for maybe 15 minutes out of every hour. So you really need 3,200 air conditioners, and some of them aren't working when you start, so you probably need 4,500 air conditioners just to get a minimum bid out on the table. But what you're really interested in is this thing called flexibility. So the grid is operated on a longer term model, and you need to understand at every minute of the day, how much flexibility does this customer have to change their behavior? Is the electric car charged or discharged? Is it halfway in between? Do I have flexibility? How long is the ride to work in the next morning? So there's a whole big machine learning step that happens down at the fleet management level to determine at any point in time, where do I have flexibility? When do I have flexibility? What can I do with it? You can't monetize even that, because you got to figure out when it's valuable. When is flexibility valuable and when does it not matter? So the next level up is the network constraints management. So you can't operate the grid on a closed loop system. The protection systems in the grid kick in at half a cycle. That's 120th of a second. So you run the grid on a forward-looking model, and you project that model out a couple of days, a couple of hours, a couple of minutes, and most of the control actions on the grid happen against the model. Now, you can also predict when things are going to go really bad. And this is your opportunity to sell value, right? When the models predict you're going to have a problem, then you have an opportunity to say, hey, I have a flexibility that I've determined in my second level up here that I'd like to sell into that market. And then you get to the next level, which is the monetization mechanism. So the cloud, again, allows you to participate in many markets. And each of those markets has different requirements. So if you want to participate in the capacity market, you need to be able to predict 24 hours out, but you need to be very, very accurate. The penalties are severe for missing your commitments. If you're going into, for instance, the reserve market, 10 to 20 minutes. You want to go regulation market, which typically isn't done like this, you'd have to go every 2 seconds. So all of this needs to be set up for you to be able to say, okay, now I can take this data that this customer's giving me and monetize it into something. And you're going to have the same issue in a number of other industries. Everyone's got these smartwatches now, routinely setting up EKGs and heart rates. My bathroom scale reports everything up in the cloud. There's a whole bunch of health information coming up that people can make available, but you got to be able to use it. You got to be able to use it constructively, and you got to be able to return value. So some of the results we've had, this is the results from one of our customers. They've got roughly 500,000 homes under control, under management. They developed their own architecture for this. They were using EC2 for a lot of the processing. We've been working with them over the last year. They have adopted Greengrass, and you can see they've got about a 60% reduction. And this is all in. This isn't just the cost of the IoT, right? This is the cost of the IoT, the S3, the EC2, that whole stack to get from zero to monetization. This is what we've been doing with them. One is Greengrass down at the edge, dramatically reduced the amount of communication back to the cloud. Also allowed some of the Lambda processing to be moved from the cloud down to the edge. On the cloud side, folding up a lot of the EC2 and moving as much as possible that to Lambda. And you can see, and the costs go down over time because it goes down as we swap out the internals of the software in their homes. But this is a 500,000 point example. And then we got an even bigger example. So one of our customers, Empress, they've done a country level DERM system. They integrated 13 different systems. This is a country that has roughly 50% hydro, 6% renewable, so kind of in the window of the average of the world, plus some nuclear plants and some coal. Hundreds of substations, geospatial information system, multiple different types of home batteries, water heaters, PVs, and all that was done in a month as a pilot, and it went countrywide in a few months after that. So these are not long-term 2, 5, 10-year type things. These are things that can be deployed relatively quickly if you've got partners with the right architecture. We got another partner here from Panoramic, now part of Centrica, and they're doing the same thing on country level scales and city level scales. So this is happening right now. So kind of the point I wanted to get across is connected home is a lot more than cranking out an Alexa skill and throwing a couple cloud connected devices in the house. That's not a sustainable home product. Customers, in fact, are generally putting in these devices themselves. But even if someone else puts in the device, the customer owns the data. In all cases, the customer owns the data about what's going on with their life. And if that's your cloud strategy, the customer will eventually tire of not getting value back, and they will take that data and redirect it to someone that can. So the big 3 things that we're working on as a group here in Power and Utilities, one is we're working with our ISVs as well as the in-house development groups of our major utility customers on adoption of IoT Core, Greengrass. This is going to become infrastructure. It used to be that was very proprietary how you did that I/O. It's now becoming infrastructure, and we need those teams to be focused on much higher level, the algorithms, the calculations, the ability to do different markets. That's where they need to be moving to, and so we're going to bring them along to that. We're also working a lot with some customers, so there's several lead pilot customers involved with this Amazon Experts program to roll out connected home at scale. And so if you go on the website, you can see some branded stuff. There's one with Lennar Homes where you can see a nice video. So it still has the utilities brand, but then there's a little fulfillment by Amazon thing happening at the bottom of that. So these are the things we're working on. This is kind of the end of the session. We've left a little bit of time for Q&A because we think there might be a few questions. It'd be really good if we could get a few of you to fill out the surveys. It's been pretty low results on the survey taking so far, so it would help Matt and I to understand a little more about what people are thinking and what kind of questions are out there that don't get asked today. Thank you. And I think we got a microphone that people can ask questions if they want.
IoTatlas.net. IoT Atlas, all together. Atlas, yeah.
Yeah. Do we get a microphone? I don't know if we do or not. Yeah, we'll repeat the question. Yeah.
Yes. So the way I see it, you kind of have two areas that need to scale. So on the onboarding of new data, new devices, you need to be able to deploy either in your generation site new gateways or new devices rapidly. So the onboarding and the configuration of those devices needs to be as seamless and automated as possible, so you don't lose a lot of time. You need to have a flexible solution so you can interact with the different APIs of all of the smart devices that you might want to be able to interact with. So you're going to need to be able to scale on the IoT side, where AWS Greengrass can help you with that. And some of our new services like the complex events might also be a good way to look at it. On the API side, you're going to have then you're going to have to scale like on the cloud side as well, right? So where all you're ingesting that data and creating those insights and making those decisions. As Ralph said, if you have a problem on the grid or if you have a weather issue or something, you're going to need to be able to scale that part also pretty rapidly to be able to really quickly make some decisions to stabilize your grid and act on the devices that you have on the side. So I see two sides that need to scale. I think the AWS suites of services can really help you with the device side and some of the ingestion part in the cloud. And I think Lambdas, machine learning service like SageMakers and things like that. Those services are going to help you a lot more on the after the data gets ingested, processing it and generating those sites as much as possible, and with the flexibility that the cloud gives you.
Yeah, NERCSIP is I wouldn't call it an issue, it's an opportunity. As you can see, a lot of the examples were actually from outside of the United States, where sometimes it's a little easier to get this stuff done. But we do have a group working directly with the NERC organization. We have a shared security model, responsibility model, where AWS has responsibility for what's happening in the cloud, but the customer still has responsibility for the apps. And so we're working on more prescriptive guidance. The tricky part with NERC is it's a pretty loose standard, and so we have to work not only with NERC, but we have to go back and start working with all the auditors to make sure they understand how to interpret the regulations from the perspective of cloud. But it's happening. I mean, more and more companies are starting to move more and more in the cloud. Internationally, it's happening much faster, and so there's a lot of good use cases and test cases that people can then look at to see how can this be done. But yeah, it'll always be a little bit of fun, and it really depends a lot on your relationship with your auditor, and there's a bunch of other things that factor into that.
Yeah, and we have a good track record on like the finance side and the healthcare industry to work out with those regulatory body, and but it does take sometimes a little bit of education and time to really have their models adapted to the cloud.
So a question around controlling devices through voice. We've seen a number of devices support Alexa, but we're also now seeing with the entry of Google's and others into the market that some other devices are being managed through Google now and so forth. So from a customer perspective, from a home perspective, what is a customer to do for, is the battle between voice between Google and Microsoft and so forth. Where do you see that thing going? And from a customer perspective, how can they use one natural language processing to manage it that is not vendor dependent, or it is not Amazon dependent or Google dependent and so forth? That's the question.
So I'm not sure I understand correctly, but are you talking from a utility perspective to be able to interact with the in a vendor neutral fashion with all of the voice assistant providers?
Yeah. Yes.
Okay. That's another reason why when you're building your system, you need to be flexible and agile, because sure, we have a lot of customers using Alexa, but maybe for your solution, you do want to include customers that have Google products or other products, and there's going to be more coming up down the road. And to me, it's the same as interacting with different type of vendors for electric vehicle chargers or thermostats or heaters and things like that. You're going to have that flexibility, be able to quickly integrate with the different vendors, so you can make sure that all of the homeowners, all of the smart homeowners, whatever they're using, you can bring that into your portfolio, your fleet of smart home, and really be able to monetize on top of that.
Yeah, if I can just throw one thing in here. Yeah, and one of the differences between what we're talking about here and, for instance, what you would do with an Alexa, if you say, Alexa, turn on the light, and the light comes on, that's great. The light's not allowed to just come on anytime it wants, right? That's not okay. And so, what the Alexa is for is to say, I give you permission to control this device, but something else is then ending up controlling the device. It's either a direct device connection through another device cloud, but you're not, not everything is being routed through the home automation, the voice activated. Voice activated is for permission and instant response, but it's not doing the actual control.
That makes sense. Thanks.
Okay. Anything else?
Any more questions?
Okay.
All right. Well, we have a little bit more time, so I think we'll probably stay around here for a little bit. If any of you guys have any question that you want to come and ask us personally. Thanks for being here today.